The Pythagorean Theorem. Vocabulary. Legs, the sides that form a right triangle. Hypotenuse. This is always the longest side of the triangle, and it is always opposite of the right angle. So here's a picture of a right triangle. You can see the 90-degree angle labeled in the corner. A and B are legs. These are the two sides of the triangle. And C is a side of the triangle, but it's a special side. It is opposite of the right angle, and it is called the hypotenuse. The hypotenuse we always use as C. Legs A and B can be either place. B could be here or here. Same for A. Vic number 1. This is the Pythagorean theorem. A squared plus B squared equals C squared. Memorize it. A and B are the legs. C is the hypotenuse. Vic number 2. The Pythagorean theorem can be used to find the length of any side of a right triangle if you know the other two sides. So this is why we have the Pythagorean theorem and when to use it. Example number 1, find the missing side. So we have two sides, and these we can label as A and B. These are our legs. C is our hypotenuse. So A and B. A is 9 and B is 12. So I'm going to plug them into the Pythagorean theorem. 9 squared plus 12 squared equals C squared. I don't know what C is yet. 9 squared is 81. 12 squared is 144. And 81 plus 144 is equal to C squared. Add these together, you get 225 is equal to C squared. Now I don't want to find out what C squared is, I just want C. The opposite of squaring is to take the square root. And there's a button on your calculator for this as well. The square root of 225. It means what number times itself gives you 225? And the square root of 225 is 15. So this side is 15 inches. Make sure you include units on the problem if you're given them. All right. Let's see if I can do this without all the boards falling. Example number 2. Find the missing side. All right, here I have 8 and 24 meters, and I'm looking for side B this time. So here is my hypotenuse. It is opposite of the right angle. There's B, so this must be A. And I'm going to plug them in again to A squared plus B squared equals C squared. So 8 squared plus B squared equals 24 squared. And 8 squared is 64. Plus B squared equals 24 squared, means 24 times 24 is 576. Now I want to solve for B squared, so I'm going to subtract 64 from both sides. B squared equals 512. And again, the opposite of squaring is to take the square root. So take the square root of both sides, and you get something that doesn't come out perfect, so let's round to the nearest tenth, 22.6. All right, and because we rounded, let's use approximate. And meters. Oh my goodness. All right, example number 3. The measures of a triangle are 5, 12, and 13 inches. Is this a right triangle? Well, this is called using the converse of the Pythagorean theorem. It says if you have the sides of a triangle and it works in the Pythagorean theorem, then yes, you automatically have a right triangle. If you plug in the 3 sides, 2a squared plus b squared equals c squared, and it does not work, then you can say no, this is not a right triangle. Now, how do you identify which ones are A, B, and C? Well, C is always the longest side, so 13 is C. The other two, the order doesn't matter. You can make either one A or B. So I'm just going to do them in order. 5 squared plus 12 squared equals 13 squared. Well, 5 squared is 25. and 12 squared is 144, and 13 squared is 169. Add them together, 25 plus 144, and you get 169. Is 169 equal to 169? Yes. So is this a right triangle? Absolutely.